Today we are going to solve squared roots. One of the things that we have to keep in mind as we progress in our solving for the variable, that's really what we've been doing all year long, is the different formats that are presented to us. And we can take a situation that we've seen and we're solving for the variable. Something that we should notice is this problem. We're going to attack this problem differently because we have a variable to the second power and then we have a variable to the first power. So the techniques that we can use are different from a problem as if we saw this problem. And notice we have still two variables. We have the same variable but to two different powers, x to the first and x to the second. But how we solve this top one is going to be completely different on what we can do to solve the second one. We can, and then we can look at a problem like this. Well, let's keep going 0. And then how we solve this one. This is completely different on how we would attack this problem. All equal to 0, but different techniques, different ways. Oh, this is what I should do. Let's do this. We can definitely use that problem, but let's do this. There we go. So where we only have one variable squared. So keep in mind in all three of these we can use the quadratic formula. That's the beauty of the quadratic formula. That is 100% of the time. Now we know that we have a times c. We can do that some of the times, not all the times. When we factor, right, maybe there's a common factor, we can use that some of the times, but not all the times. And today we're going to use solving squared roots. So squared, isolating, solving for squared roots. So that's going to be very particular too. It's not something we're going to be able to do 100% of the time. So keep in mind and be aware of some of the characteristics of these problems today, that what they have that maybe a problem like this would have or this would have. So there's some very, very clear things. So if we look at this, first thing we see is that we have a single variable that is being squared. So isolating or we're solving for n, so we need to get rid of that square. Well, what gets rid of a square root? What's the inverse of a square root? Square, excuse me, I already told you, hello, yeah, is a square root. So when we have this, if we want to get rid of this square value, we're going to take the square root. So we'll take the square root of both sides. And something that we talked about in class is whenever you take the square root of a variable being squared, you must introduce you must include, you must add, plus or minus to your solution. And we'll discuss why that is the case. So in this case, since we did this, the square root and the square, they're going to cancel. That leaves me with n. And now we have to put a plus or minus. And we love 64 because it's a perfect square, and that equals 8. So the solution to this is going to be plus or minus 8. Plus or minus 8. Positive 8 or negative 8. And the reason being that plus or minus is because when we square a value, if we plug it back in, if n squared equals 64, and we notice that if we plug in negative 8, well, negative 8 times negative 8 is going to give me 64. So that's a solution. Because this variable is being squared, it's going to produce the same value whether it was negative or positive, because 2 negatives make a positive, 2 positives make a negative. So it didn't matter whether it was a negative value, because it's being squared, it will come out as a positive value, much like its other side of that, which is the positive 8. So we have b squared, so we're going to take the square root of b squared. You can introduce it here once we take the square root of a variable being squared. We're going to put plus or minus. Square root of b squared gives me b, plus or minus. 100 is a perfect square, so plus or minus 10. As nice and easy as that. Number 3, again, we have p squared. It's isolated. There's nothing multiplying p. There's nothing dividing p. There's nothing adding or subtracting to p. So we've isolated p, the variable p, but it's being squared. But I'm not solving for p squared, I'm solving for p. So I have to get rid of that square. And what gets rid of a square is a square root. So the square root of p squared is p plus or minus. Now 24 is not a perfect square, but I can simplify that. So I'm going to break it into some factors that have a perfect square in it. And I chose 4 and 6. I didn't choose 3 and 8 because 3 is not a perfect square, meaning I didn't break up the square root of 24 to the square root of 3 times the square root of 8. That's not beneficial to me because neither is a perfect square. So of the choices, of the factors of 24, rad 24 that I can break them into, I'm going to look for a perfect square. And 4 is a perfect square as a factor of 24. So that's why I chose it. So my solution is plus or minus 2 rad 6. And rad 6 can't be simplified any further. Number 4 is a little bit different now, because now my x, my variable, isn't isolated. It's being added to 8. So I have to get rid of that positive 8 by subtracting 8. That gives me x squared equals 4. No plus or minus yet. And the reason why I don't have the plus or minus is because I haven't taken the square root of a variable. So don't get that plus or minus in there until you do this step. That's when we start including it. And now square root of x squared is x equals plus or minus. Rad 4 is a perfect square. So my solution is plus or minus 2. Number 5, my variable is not isolated. It's being multiplied by 16, so I'm going to divide by 16. I got x squared equals, I think that's 4, 24. Yep. And now I've got my variable isolated. I need to get rid of that square. And I get x equals plus or minus 2. n squared equals 16. I'm going to divide by 25. I've got my variable isolated. Now 16 over 25 cannot be simplified. No number goes into 16 or 25. And I can't take the square root of it because there's no square root at the moment. But once I need to isolate my variable, which is being squared, now I have this. And now square root of a square gives me this, gives me n plus or minus, again, 16 over 25, but I can separate them because it's being divided. I can separate, much like I separated rad 24 into different houses. I can also do that with division. We can only separate things being multiplied or divided. And now I'm gonna simplify it. Rad 16 is a perfect square, and rad 25 is a perfect square. So my answer is plus or minus 4/5. We like that. We love it when we can see some perfect squares in those. All right, 49v squared plus 4 equals 40. So now I got two things happening to my variable. So I'm going to get rid of things being added and subtracted. 49v squared equals, that's going to give me 36. Now I'm going to divide by 49. We get v squared equals 36 over 49. That can't be simplified. No number goes into 36 and 49. So I'm going to take the square root of both sides. I'm not going to forget my positive and negative. So the square root of v squared is v plus or minus. And now I'm going to separate each of those and see if I can simplify those. And they can, because both are perfect squares. And I get plus or minus 6 over 7. Okay, 81n squared plus 5 equals 41. Let's subtract 5. I get 81n squared equals, what's that, 36. Divide by 81, divide by 81. Ooh, this is a good one. This is a good one. So we get n squared equals 36 over 81. So I can simplify this fraction. I know that 9 goes into both of those. 9 goes into 36 4 times, and 9 goes into 81 9 times. So I was able to reduce that fraction before getting rid of that square. Now I want to get rid of that square, so I'm going to take the square root. Square root of n squared gives me n plus or minus. I'm going to put these in separate houses. And I get n equals plus or minus 2/3. Because the square root of 4 is 2, and the square root of 9 is 3. And let's see if we got some more. We got one more? Oh, we got 3 more. Let's subtract 6. Oof, this is a big one. 378, I think it is. 378, yes. 2 gets me to 80 for you. Divide by 7, divide by 7. P squared equals 378. I don't know that one. 378 divided by 7 gives me 54. So equals 54, whole number. Okay, let's find the square root of p squared plus or minus square root of 54. Square root of p squared is p plus or minus. 54 is not a perfect square, but I know there's a 9 in there. So p equals plus or minus 3 rad 6. Plus or minus 3 rad 6. Rad 6 can't be simplified any further. So there's my answer. Ooh, not in standard form. So what are we going to get rid of? Well, I'm going to get rid of that constant. What gets rid of a negative 5 is a positive 5. Negative 6r equals negative 6. We're going to divide by negative 6. We get r squared equals positive 1. We're going to take the square root of r squared. We get r equals plus or minus 1. Plus or minus 1 is my solution. Oh, jumped too quickly. Minus 8, 9x squared equals 243. Divide by 9, divide by 9. X squared equals, and what's that? That's 610. Ooh, that does, no, it does not. So, oh, that's 5 and 9. Yes, it does, sorry. 2 plus 4 plus 3 is 9, so 9 goes into it. 2, 4, 3 divided by 9 gives me 27. So 27 square root of x squared equals plus or minus rad 27. See, square root of x squared is x equals plus or minus 27 is rad 9, rad 3. And I get plus or minus 3 rad 3. And that's going to be my solution. Okay, so hopefully you went through those steps in order to simplify or to complete your homework. Come and see me.